Hi guys, and welcome to the grade 12 math session. I've got Liesel standing next to me. How are you?
I'm very well, thank you. Looking forward to doing some sequences and series tonight.
Fantastic. So, questions. They should send through any questions they may have.
Absolutely any questions. Guys, please send them through. We don't know what areas you're finding difficult if you don't let us know. So please.
Exactly, and the only silly question is asked after the exam when it's too late, right?
Absolutely.
Okay, take your spot while I tell them a few things here. Okay, guys, what you need to do is you need to join us on facebook.com/learnextra, and that's the page we'll be posting all of your questions. You'll be helping out other mindsets, because remember, this is a community not just for us, but it is for you guys too. Having a look at the Facebook page, we are nearing 30,000 at a rapid rate, which could be quite amazing. We've got almost, I don't know, like about 520 to go. So do you reckon we can get 520 grade 12s in an hour? Anything is possible. Okay, and what I do need to tell you, which is very exciting and super, super awesome, I will be posting the link onto the page, so do not fret. But if you do have a pen and paper, here it is. It's www.mindset.co.za/learn/extra/live. And what that's going to get you guys, it's going to get you our schedule, our entire schedule, but what it's also going to have is downloadable notes. You can go and click and download the notes for this very session, as well as in about 3 days' time, the video from today's session will be up. So this is going to be an amazing resource for you for the entire year. So this is going to be a link that you're going to be clicking on a lot. But don't fear, I will be posting everything on Facebook and on Twitter. So if you missed any of those URLs or any of that kind of stuff, not to fear. But I'm not going to take any more minutes away from your very important lesson. Liesel is gearing up and she is ready. Take it away.
Right, guys, so today we are looking at sequences and series. You guys were introduced to sequences and series in grade 11. Remember the quadratic number pattern. If you've forgotten those, keep track of our grade 11 lessons, because that's bound to come up quite soon. So let's have a look at what we're going to do today. We're going to look at the two different types of number patterns that we need to work with in grade 12. That is our arithmetic or linear number pattern, and the other one, our exponential or geometric number pattern. We're going to have a look at the different formulae that we need to use. We're going to have a look at how to identify the different number patterns, and then finally we're going to look at converging geometric number patterns. So that's all that's in store today. So I'm going to spend the first 20-25 minutes just quickly taking you guys over the basics, making sure that you know how to identify which formula you need to use, and so on. So let's get going. Right. So I've started out with our arithmetic number patterns. Now I would say that the most important thing is that you know how to identify an arithmetic number pattern. That's pretty straightforward. I'm going to use a simple example: 2, 5, and 8. Now, guys, most of you would have been able to identify this in primary school already. What did I do to get from 2 to 5? I added 3. What did I do to get from 5 to 8? I added 3 also, and that identifies this number pattern as arithmetic or linear. So the first thing that we will notice is that the second term minus the first term is equal to the third minus the second if our number pattern is arithmetic. Now, guys, I know it's pretty obvious in this example, but sometimes they get a lot more complicated. We throw a couple of x's in the mix. So bear in mind, this is how I prove that my number pattern is arithmetic. 8 minus 5 gives me 3. 5 minus 2 also gives me 3. Therefore, I'm dealing with an arithmetic number pattern. And guys, that is the most important thing with number patterns. If the number pattern is given to you, identify the type of number pattern that you are working with, because that will determine which formula you're going to use. Absolutely very, very important. If it's not possible for you to identify what type of number pattern we're working with, they will have to tell you. And we'll look at examples like that a little bit later on. So, we've already said that from one term to the next, we are dealing with a constant difference, and that constant difference in the example that I used was 3, because to get from one term to the next, I added 3. Now, let's have a look at our formulae. The first formula that I have over here, Tn is equal to A plus n minus 1d, is the term formula for an arithmetic number pattern. So, if you are asked something like, calculate the 10th term, then, or you are asked anything to do with a term, or which term is equal to 243, or whatever, whenever you see the word term, you will be using the term formula, provided the number pattern is arithmetic. Just to quickly go over what everything stands for, Tn stands for which term you are looking for. So if you are wanting to calculate the 10th term, you'll say T10. A stands for the first term. So that is the first term in the number pattern as it's given to you. N, again, is the term number that we're working with. So if we're looking for the 11th term, N will be 11. If we're looking for the 4th term, N will be 4, and so forth. And D is our common difference, which we've just discussed. That is what we add from one term to the next. And it doesn't necessarily have to be addition. This is also an arithmetic number pattern. Have a look here. 16, 14, and 12. What do I do to get from one term to the next? I subtract 2. And what you'll find if you say 12 minus 14, you'll get minus 2. 14 minus 16 gives you minus 2 also. So don't stress if the number pattern is descending. It can still be arithmetic. It's not a problem at all. Right. Then the next formula, and guys, remember, these formulae are given to you on your information sheet, so you don't have to commit them to memory, but we don't tell you which formulae are for arithmetic and which are for geometric, so you need to be able to recognize them. That's very important. The next formula is the sum formula. So if I give you an arithmetic number pattern, I might give you the first 3 terms, and I say to you, calculate the sum of the first 100 terms. Then you know that I'm looking for a sum. The word sum will either be mentioned, or you'll see words like altogether or in total. That also indicates to you that you are dealing with the sum formula. Now, we're going to get to the examples a little bit later on. Today, we're going to focus mainly on arithmetic. Next week, most of our examples will be geometric. However, I'm going to quickly do the discussion for the geometric number patterns with you guys now as well. Right, so Indy, just at this point, before I go on to the next topic, anybody unsure, anything that anybody needs to know?
I think at this point in time we don't have any questions coming through, but I think, guys, please post them on the page, and I think when we come back from the next break, hopefully Lise will be able to answer some of those.
Absolutely. We've already had some questions via email, so that's really great.
Fantastic.
Right, so now let's have a look at a geometric number pattern. Geometric number pattern is also called exponential. Remember your exponential graph, it goes up very quickly, and the same is true for a geometric number pattern. Let's have a look at the example 2, 4, 8, 16. This is a very simple example, but we're still at the very beginning, so we need to make sure that everybody's on the same page. So what has happened here from one term to the next is that I have multiplied. So I've multiplied the 2 by 2, the 4 by 2, and the 8 by 2. So whenever we've got a multiplication situation going on, then we know we are dealing with a geometric, also called an exponential number pattern. So let's have a look at some of the properties for a geometric number pattern. Remember, for the arithmetic, I said the third minus the second is equal to the second minus the first. Now this works a little bit differently. Here, in order to prove that our number pattern is geometric, we will take the third divided by the second and make sure that it is equal to the second divided by the first. So in other words, 8 over 4 gives me 2. So does 4 over 2. So I can then conclusively prove that I'm dealing with a geometric number pattern. Guys, I know it's pretty obvious here, but as I said, as with everything in life, it does get more complicated. Right. So let's talk about the terminology. For an arithmetic number pattern, we spoke about a common difference. So that was what you subtracted or added from one term to the next. Now, for a geometric number pattern, we talk about something called a constant ratio. And that is that multiply by 2, multiply by 2, multiply by 2. Just before you guys think that exponential number patterns always have to go bigger and bigger, remember we get exponential graphs in both directions, and the same thing for number patterns. If I have a look at this number pattern, 100 followed by 50 followed by 25, this number pattern is also geometric. Now, I know you guys will be very inclined to say, ooh, I'm dividing by 2, and that's absolutely true. I am dividing by 2, but there isn't a space in our formula for division, so we've got to think, what can I multiply with that's equivalent to dividing by 2, and that is I'm multiplying by a half. Right, so my constant ratio in this case will be a half. And again, my initial formula checks out perfectly. 25 over 50, when I simplify that, it gives me a half. 50 over 100 simplified is a half also. Right. Now listen, guys, remember, if you feel I'm going too fast, as Indy explained to you, the video and the lesson notes will be available. So you can always go back and see, what did she say again? What was she on about? Because we do have a bit of a time limit, unfortunately. Right, so now, moving along to the term formula for a geometric number pattern. Let's say I was given 150 and 25, and somebody said to me, calculate the value of the 50th term. The moment you see that word term, you know you will be dealing with the term formula, and make sure that you select the right one. If it's a geometric number pattern, it needs to be this one. If it's arithmetic, you've seen the correct formula. Right, so let's have a look at what everything stands for. Tn is very much the same. N stands for which term. A is the first term in your number pattern. R is your constant ratio. So let's say in this number pattern, I wanted you to use a formula to calculate the 7th term. Obviously, I'll be less cryptic in an exam. Then you will say, all right, she is asking me for a term, and the number pattern is without a doubt geometric, so I'm going to select this formula. Term number 7 is equal to A, my first term, which is 100, multiplied by R, my common ratio, and we said that that's times a half. And that is then to the power n minus 1. Now, n is 7, so then 7 minus 1 gives me 6, just like that. And there you have it. You can use that to calculate your 7th term. Let's have a look how we'll do that. We'll say 100, open bracket. You can put in a half or 0.5. That's fine. To the power, and the power was 6. And that will be 25 over 16, which we expect because it's getting smaller and smaller and smaller. Right, so that is our term formula for a geometric number pattern. We get then to the sum formula. Remember, whoops, the gremlins are back. Remember, guys, the sum formula, we're either looking out for the word sum or keywords such as in total or altogether. Some of you might think that I've left out one of the formulae. Let me just write the other one down. These two are equivalent. You can use either or. So all I've done is I've inverted the bracket. And once again, A stands for the first term, R stands for the constant ratio, and so on. Right. I know that's a bit of an information overload. We're going to first have a look at one or two questions after the break, and I think then a little bit later on in the show, I'll speak to you guys about sum to infinity and converging number patterns. Indy, over to you.
Okay, let's take a break, guys. Matrix, you guys. I haven't told you guys yet, which is very important. Please go and vote for our top 10 Mindset social media presenters. What you need to do is you need to go to our Facebook page and you have a look for our top 15 It's in an album, and you like your top 10. At the end of the show, voting is closed. We will have our top 10, and sometime this week we will be announcing who our new presenters are. So you better be watching this space. Vutoshilo, Anele, Lisa Mile, Puti, Maladzi. Let's have a look. Sive, Mosa, she's always on the page, and Sako. Guys, I am seeing all of your messages, and keep posting, keep helping each other, because this community is not just for us, it's also for you. See you after the break. Hi Matrix, welcome back. And you know what I want to say to you guys? It's so nice that you are all starting early. The page is pumping, and that's what we like to see. Anela has said, okay Matrix, we are the class, so let's make every moment count, distinctions looming. I promise you, if you guys stick with Mindset Learn and you follow the lesson straight from the beginning of year all the way to the end, you will be fine. And this is my promise. This is my promise to you. And I'm wondering, I can see Liesel's also shaking her, well, she's saying, nodding her head. So hopefully, two promises.
If I was shaking my head, that would be a problem.
Yeah, two promises to you. Okay, and just one quickly. Archie says, hey guys, thanks for the lessons that we're getting from you. It means a lot to us. By the way, I'm one of those who'll be writing supplementary exams starting on the 15th. So I'd appreciate it if you try and explain very slowly so we can understand well. Thanks. Now, Archie, good luck for your supplementary exams. For the rest of you also writing subs, please tune in every morning. We have supplementary exam school just for you. And if you are writing subs, hopefully you are also paying attention in this here lesson. I think, Liesel, time to take it away.
Right, and guys, also as we mentioned before, now that you can view the video as well as the lesson notes on the website, even if we're not going slowly enough, maybe you can put us in slow-mo or just pause us every now and again.
Exactly.
Right, so I've got our first question on the board for us. So let's have a look at what it says. I'm going to go really slowly, yes, because I want to be absolutely sure that you guys know how to approach these questions. Right. It starts with given the sequence, and we've got 26, 24, 22, and then ... negative 12. Now, before I read any further, I'm going to make the decision arithmetic, geometric. Now, this one is a bit of a no-brainer. I think most of you will be able to see that to get from 26 to 24, I am subtracting 2, and to get from 24 to 22, I'm subtracting 2 as well. You only need 3 terms to be able to determine whether it's arithmetic or geometric. So, the first thing that I would write down for myself is that it's arithmetic. And remember why 22 minus 24 is negative 2, 24 minus 26 is negative 2 as well. Now, whatever you do, don't start using the formulas for geometric. It's just not going to work. Trust me, I know. Right, so let's have a look a little bit further. They say, determine the number of terms in the sequence. So, according to the question, the sequence starts at 26, and it ends at negative 12. And obviously, a whole lot of things had to happen in between so that you could get to negative 12. So they want to know from us, how many times do I need to repeat this process of subtracting 2 in order to get to minus 12? Now, guys, the bad news is it's not going to work to just sit on your calculator and go minus 2, minus 2, minus 2, minus 2. You have to use the formulae. Right. So the first thing that I'm thinking about is, which of the 2 formulae will I use? Will I use sum or will I use term? Now, there has been absolutely no indication to me that I might have to use the sum formula. The word sum was not mentioned. I didn't see a plus sign, and nowhere were there words like total or altogether. So I'm selecting to use the term formula, which I'm now going to write down. So now's the time to fill in what I have and what I need. Now, my unknown term, my term that I don't know the number of, T question mark, also known as Tn, is negative 12. So negative 12 is placed in the place of Tn. There I put my minus 12. Right. As I mentioned before, A stands for the first term, and the first term is 26. So in it goes, plus, and then n minus 1, and my common difference from one term to the next, that's negative 2. Indy, I'm just going to go to you for 2 seconds just to find out if we got any questions so far.
Okay, let's have a look. Looking. Cabello has said to me that I must say hello to you, Liesel. So Cabello says hello and says
I've
don't.
got Cabello's question for later on. I've
Do
actually
you?
got it. Yes, he
Yay!
emailed it through earlier on. So
Yes, Cabello.
we'll get to you next.
Your question lives, Cabello.
I hope it's the same one. I hope it's the same one. There might be more than one Cabela out there. All right, but
Well,
there's no questions so far, Indy.
No, nothing that is. What I want to say to the mindsets is, guys, if there's anything that Liesel's going over that you don't understand, let me know on the Facebook page. Try and not post new things that we will be going over. Guys, we will cover everything throughout the year, but let's go through sequence and series today, sequence and series questions, and post now.
All right.
Yeah.
Okay, so let's get on with it. There's no problem here. The rest we have to do is very straightforward algebra. I've got my 26 over here. I'm going to say negative 2 multiplied by n, so that's minus 2n. And negative 2 multiplied by minus 1, that's plus 2. Right. So I'm going to, you can do it any way you want. I'm going to put my 2n over here on this side. I like having those on the left-hand side. And then I've got 26 plus 2 plus 12 on the right-hand side. And that gives me that 2n is equal to 40. So n is equal to 20. So there's 20 terms in the sequence, or if we repeat the process of subtracting 2 from 26, we will get to minus 12 after 20 times. Now, guys, it's very important that we remember that n is like a place in a race. Your answer has to be a positive whole number. I can't say that you're such a terrible athlete that you came minus 20th in the comrades, right? That doesn't work. I also can't say, oh, I'm so excited, the Bafana were minus 2th in the AFCON Cup, or 2th in the AFCON, 2.5th in the AFCON Cup. So it has to be a positive whole number. Right, so pretty straightforward. Whenever they ask us the question, which term or how many terms are there in the sequence, we will substitute our unknown term in the place of Tn, and we will be solving for n. Right, this question gets more complicated rather quickly. There's a second part to it. So let's have a look. The next question still deals with my same number pattern, 26, 24, 22, all the way down to minus 12. And it now says, how many terms must be added to get a sum of minus 1,224? Now, guys, the words added and sum indicates to me that I will be using the sum formula. Please, it's still the same number pattern, so I'll be using the sum formula for an arithmetic. Let's write that down. Now, it's an interesting question here because every time I have to work out how many terms. So in both of these questions, the unknown that I've had to solve for is n, how many terms. Now, it's not so tricky if you're dealing with the term formula, but it can get a little bit more tricky, just the algebra, if you're dealing with the sum formula. Let's get on with it. Right. So how many terms must be added to get a sum of minus 1,224? So my S unknown, how many terms must I add to get that? Also known as my Sn, is then minus 1,224. So minus 1,224 equals. Now I'm solving for n, so don't freak out. Don't worry about the fact that there's nothing in n. And please, whatever you do, don't put minus 1,224 in the place of n. That's just going to be messy. Right, so on with the algebra. 2 times a, my first term. Remember, the first term is 26. And plus n minus 1 And my common difference from one term to the next, I subtract 2. And remember to add in this minus, guys, because it's just really not going to work out at all if you don't. Right, so now I'm just going to do a little bit of tidying up here. It's kind of like washing the dishes after supper. What I'm going to do is I'm going to work from the inside out. So I'm first just going to deal with my bracket. I'm going to say, all right, 2 times 26 is 52. Then minus 2 times minus 1 is 2. And minus 2 times n is minus 2n. Okay. So some more housekeeping inside my bracket, guys. You really don't have to show this many steps. I'm just trying to make it as easy for everybody as possible to follow, but you don't need to stress out. Now what I need to do is I need to distribute my n over 2 into the bracket, and that's not going to be hard. I'm going to say n over 2 times 54 over 1. Remember, it's over 1 like that. 2 goes into 54 27 times. So I get 27 n, and I get negative n squared. And what happens is that the 2 and the 2 there cancel each other out. Right. Now you guys should be able to see that what I've got forming here is a bit of a trinomial. Right, so I'm going to multiply out until I get my solutions here. It's going to be n squared minus 27n minus 1,224 equal to 0. Now, guys, this is a bit of a difficult quadratic to solve. I don't know about you guys, but I'm not that well versed on the factors of 1, 2, 2, 4. But what can you do? You can, of course, use the quadratic formula. But just to save us a little bit of time, I've gone and looked it up for us. So it's n minus 51 and n plus 24. Right, so remember, your quadratic formula is what you will use here. Now it's time to write down our answers. Now our answer is either 51 or it is negative 24. But now remember, guys, what did I say just now? N is like the place in a place in a race. You can't be so bad that you came negative 24th of. So the negative answer you can just lightly cross out or write underneath it, not applicable. Right. So this is a really, really nice question. Both cases we had to solve for n, and I have to be honest, that's probably a little bit harder than just calculating the 10th term or so on. So we said we were going to get to a viewer's question, and I just, even if we do have to take a break quickly, I just want to get the question up so that everybody can see. And now I don't see the question.
Well, what we can do is I've got a few questions here on the page.
Okay, we can do
And
that
then-
in the meantime.
yeah, and
Otherwise,
then
I
when
can
we
just
get
write
back-
it on the board.
And then when we get back from break, then we can go over, whose question was it again?
I think it was
Takalani.
Capano, and I did write it down, so it's not a problem. We can find
Okay, well,
it.
we have a whole bunch of mindsetters, the usuals. We've got Monty. I want to say what's up to all of our regulars. Monty, Takalani, I can't believe you're in matric already. Chafikwa, Makosi Jale. So, guys, I'm so glad that you are tuning in to learn more and learn extra nice and early in the year.
Before
which
you
makes me
ask
very-
the questions, India, I just quickly want to talk through the questions so that maybe our guys can try it during the break. So this is one of those questions where our information is a little bit cryptic. They say to us, I didn't write it all out now, but just listen to me. Given an arithmetic number pattern where the 5th term is 0 and the 13th term is 16, they ask us to calculate term 1, term 2, and term 3. Now, very important, guys, just from this bit of information that the 5th term is 0 and the 13th is 16, you can't actually see that it's arithmetic. So the question will state that it's arithmetic. Right, so while everybody thinks about that, over to you, Indy.
Okay, what we're going to do, guys, is we're going to have a little break because I'm going to grab Liesel, and Liesel's going to have a look at all of these questions on the page. I think that's the only way we're going to do it. And keep them coming throughout the break and work through the question that Liesel's given you. I know how much you love a challenge. See you now after the break. Hi Mindsetters, grade 12s, welcome back. We are moving into the last 20 minutes of the show. Keep those questions coming. We're going to go through as many as possible. Guys, if you know anyone that can or does do content, educational content, they need to email content@mindset.co.za. Tell your parents, tell your teachers, and tell them to send it through. I'm not going to waste any more time. Liesel, let's get going.
Right, guys, I put the other question up just before the break, but I've had a look at Indy's computer during the break, and I've just seen a couple of questions. A couple of people were incredibly worried about this step over here. How did I get from n over 2 times 54 over 1 to 27n? Guys, 54 divided by 2 is 27. That's how I got there. Right, so if you're struggling, just do 1 over 2 times 54 over 1. Your calculator will give you the correct answer. Another question that we had also pertaining to this question, I thought I'd explained it very well, but you know, somebody on the website said, but why are we not allowed negatives? Now guys, I am asking you, how many terms must you add together? Now, if I ask you, how many pairs of shoes do you have? Can you say minus 12? Does that even make sense? Now guys, a term is just like a shoe. It's a thing. And you can't have a negative number of things. Therefore, we have to have a positive whole number. Right. I hope that clears it up. Then there was another question that I really liked. It wasn't about this one. It was Takalani, who always asks really nice questions. He said, how do we generate a general term if we've got an alternating situation or a geometric and an arithmetic situation going on? Now, before we get to my question before the break, I'm going to use this example. Let's say I've got here 2, 6, 18. Okay, I think 3 terms are enough. In the numerator of a fraction, and then in the denominator I have, let's say, 1 plus, what shall we add? Indy 4, 5, and 9. Now, if we have a look at the numbers, 2 over 1, which is 2, 6 over 5, 18 over 9, which is 2 again, there will be no obvious pattern to us, and we'll obviously want to put our hand up and say the teacher's made a mistake, but it is possible to break the fraction up into its different parts and look for a pattern in the numerator and also look for a pattern in the denominator. So maybe if we do this in a different color, if I look at 2, 6, and 18, I can see that if I look at those numbers only, I've got a geometric number pattern going, right? So what I'm going to do is I'm going to write down a general formula just for the top. So because it's geometric, I will use the geometric number, the formula, geometric term formula. So I'm going to say 2 times A, my first term 2, times R, the common ratio 3, to the power n minus 1. Now remember, if it's a general term or an nth term, we don't fill in n. So I'm going to leave that just like it is, and I'm going to say, fine, let me look at the purple side of things. And what's happening over here? To get from 1 to 5, I add 4. To get from 5 to 9, I add 4. So clearly, I'm dealing with a little arithmetic if I'm just looking at the denominator. So I write down in purple my formula for an arithmetic, a plus n minus 1d. And then I can say, right, my first term is 1. N I don't need to fill in. My common difference is 4. And I can simplify this guy here. This is going to give me 4n minus 3 once I've simplified. And then I can say, but hang on a second, I've got something different going on at the top and at the bottom. So my general term is the top is governed by this formula over the bottom, which is governed by this formula. And then if you wanted to calculate the 10th term, then you would still just put 10 in the place of n. So these sorts of things do come up. Another question that we had is, are you guys going to ask these things straightforward like this, or are you going to chuck in some X's in the exams? Guys, we don't set the exams, but yes, the X's can get chucked in. But as long as you don't get thrown by them, decide, know what you're going to do. It shouldn't be that difficult. And I'll show you guys an example where I've got X's. If I have 2x squared, and then 4x squared, and then 6x squared. Now, guys, you're in matric. You know what I had to do to get from one term to the other. I had to add 2x squared, right? So if I now ask you to calculate the 10th term for me, there is absolutely no reason why you have to panic. If the terms in the question are in terms of x squared, then your answer is allowed to be in terms of x squared. So, first things first, arithmetic or geometric. This one is arithmetic. I'm going to write down my formula, a plus n minus 1d, and I'm going to say, right, I'm calculating the 10th term. The first term is 2x squared. 10 minus 1 gives me 9. The common difference is also 2x squared. And I get 2x squared plus 18x squared, so the 10th term will be 20x squared. And there's no shame in that. So, guys, don't be freaked out. Just follow the same steps. We will be looking at the more complicated looking things a little bit later on. We just don't want you guys to get sidetracked by the X's at this point. Now, I'm going to go back to, I think it was Kupano's question. Was it?
I think so, yeah.
That we had before the break. There we go. Let's just take it down. So just ignore the rest of it. It says, in an arithmetic number pattern, term 5 is 0, term 13 is 16. Calculate the value of the first three terms. Now, guys, when the information is cryptic like this, we have to tell you arithmetic or geometric. I didn't write it out, but the question would have said arithmetic. Right. So this is how we do it. Kupano, hope that you're listening. I'm going to do a simultaneous equation, and I'm going to write down my term formula for an arithmetic, and I'm going to write it down twice. Once for this side, and once for this side. Now, guys, this is why we were taught simultaneous equations, not so that we can do them for themselves, so that we can use them to calculate other problems. Right, so let's have a look. Tn is 0. Okay? I have got absolutely no idea what A is. Nobody's told me, so I'm leaving that blank. N is clearly 5, so I'm going to say 5 minus 1, which will give me 4D. So what I've got here is an equation with A and D not calculated. And I'm going to do exactly the same on this side. The 13th term is 16, so I'm going to say 16 is equal to A, the first term, don't know what it is, plus N, I know is 13 because I'm told it's the 13th term. 13th minus 1 is 12. And then we're in the situation where we've got two equations and two unknowns. And you can solve these simultaneous equations any way you like. You can do substitution. You can equate them. You can do elimination. For me, what makes the most sense would be to isolate the A in each case. So I'm going to put the A on its own on the left-hand side. I'm going to say A is equal to minus 4D. Great. Actually on the right-hand side, sorry. So leave the A over there, and that's 16 minus 12D. So if A is 16 minus 12D, but A is also minus 4D, obviously I can equate the two to each other. So I say minus 4D is equal to 16 minus 12D Okay, guys, now it's simply just a case of getting everything on the same side, or on the correct side. 8D on the left, 16 on the right. So the common difference works out to be 2. So now I've calculated one of my two variables. I know that the common difference is 2. In order to get the first term, I can now substitute back into either one of these two equations. I'm just going to put it back in here, and I'm going to say A is minus 4 times whatever D is, and D is 2. So the first term is negative 8. I know we're heading for a break, but now let's do it. Minus 8 is the first term, and every time I'm adding 2. So it's minus 8, minus 6, and minus 4. So that would be my first three terms. Kupano, I hope you were listening. Guys, we're going to go to a quick break, but another question after the break.
Okay, Vuchilo says, never thought I'd say this, but I love math and I'm enjoying it. Big smiley face, which is awesome. Guys, we're going to take a quick break. We're going to come back with 10 minutes. We're looking over your questions. Let's do this. See you now. Hi guys, and welcome back to the last 10 minutes of Learn Extra Live Maths Grade 12. I want to say big up to all of you guys that have actually downloaded the show notes and are going through the show notes as we are. I know a few of you are having problems with downloading onto your cell phone. We are going to figure it out because we want you guys to get these notes and work along with us. So now, I think Selo, who has downloaded the notes earlier this morning, he's saying, Liesel, please help me with the last question. He's been working on it and he's struggling.
Okay, well,
Yeah.
Selo, we actually might not have got to it, so thank you very much for sending through your message. Now we will do it. For those of you that are seeing it for the first time, let's read through it together. It's one of those story sums, one of those things that we chuck at
They're
you
favorites.
to make it harder. But the key is just to extract the necessary information. Right. Alan was delighted to learn that he had won the Customer of the Month award at his local bank. A computer would adjust his account on a daily basis by adding an amount according to the following sequence. So, what's basically happening here is on day 1, the bank is going to say, well done, Alan, you're going to get 180 Rand. Then the next day, the bank's still giving him money, but not quite so generous this time. The next day, he gets 160 Rand. The next day, he gets 140 Rand. 120 Rand, and so on. Now, before we start worrying about the banks, let's just look at this number pattern. This is, without a doubt, arithmetic. What is happening from one day to the next? I am subtracting 20. Okay, right. So let's have a look at the actual question. They say, if Alan had 300 Rand in his account on the day that the first amount was added, calculate the amount in his account after the 9th prize payment. Now, guys, we don't want to calculate the 9th prize payment. We want to calculate the first 180 plus the 160 plus the 140 plus the 120, 9 times, add it all together, how much money is there in his account? So, guys, sneaky way of really asking you to use the sum formula. So I'm going to start off by using straight up sum formula and sum formula for an arithmetic number pattern, because we've already established that it's arithmetic. Right. Now I'm going to worry a little bit later about the fact that he had 300 bucks in his account on the first day. I can calculate his total prize money and then I can add the 300 Rand later on. So that's not a problem. Okay. So I need to know how many payments, how much money he has altogether after 9 of these prize payments. And I'm going to get going on that. I'm going to say sum to 9 is 9 over 2. My gremlins are back. 9 over 2. 2 times the first amount, or the first number in the sequence, and the first amount that was added to his account was 180 Rand, plus n minus 1d. Now, n is 9, so 9 minus 1 is 8. And d is the common difference. And guys, this is very important, really, is it's becoming less and less and less. So it's a minus. So absolutely, you've got to remember that minus. Now, guys, all you're going to do at this point is put this into your calculator. I'm trying to save as much time as possible. So I'm saying the prize money that he gets from the bank, the first day plus the second day plus the third, all the way up to 9, is 900 Rand. So that's really quite generous. But he also had 300 Rand in his account to start with. So the total balance of his account is 1,200 Rand. Remember, the question said, calculate the amount in his account after the 9th prize payment. Right, so I hope that didn't go too quickly. We're going to have a look at the second question. So we are still dealing with Alan, and his prize that he got from the bank. So now it says, Alan was keen to know after how many days he would receive a total of 840 Rand from the Customer of the Month award. He is also puzzled when he looks at his answer. Now, don't worry about that now. When he noticed 2 answers for N. Right. Check his calculations and suggest whether there is a reason for rejecting one of the values. Now, what we're going to do is we're going to use the sum formula again because we're dealing with his total prize money. So I'm going to write down the sum formula. Sn is equal to n over 2, 2a plus n minus 1 and d, which is the common difference. Right. Now, we are calculating for n because the question very clearly says after how many days. So after how many days does he have a total of 840 Rand in prize money? So I'm going to put 840 in here because that's my S unknown. Then I'm going to say n over 2, I'm solving for n, 2 times the first term, which is 180. Now, these guys can be a bit tricky. There were a lot of questions on this one just now when we were solving for n in this formula in particular. So make sure that you pay careful attention now. And then plus n minus 1. And remember that common difference is negative. So up to this point, it shouldn't be that difficult. Just remember, whenever you are looking for n, you need to know your Sn, and your Sn is 840. Right. Okay, guys, so now what we're going to do is we're going to get on with the business of multiplying out, and that's very, very important. So I'm going to first start by tidying up the inside of the bracket like we did before. There seems to be a bit of problems with this algebra, so I don't mind going over it rather slowly. So this gives me minus 20n and then plus 20. And that is equal to 840. Right, let's tidy up the inside of the bracket some more. So I get 380 inside the bracket and negative 20n. Now, this was the point just now where you guys started having all sorts of questions, and there's nothing wrong with that. What I'm going to do now is I'm going to distribute the n over 2 into the bracket. Now, guys, then it becomes 380 n over 2. So that's very important. I am saying n over 2 times 380 over 1. So the 380 is going to be divided by 2. That is really, really important. Okay. And then once again, when I do that, I'm going to get negative 20n squared over 2. So that's going to be 20 over 2, which is 10. Now, I'm going to have to leave you guys to deal with that algebra. If I bring everything to the same side in my trinomial, I just don't want us to run out of time. So it's 20n squared What you could also do, and this is in fact what I did in the solution here, is you could multiply the whole expression through by 2. Perhaps that's what some of you did, and that way you got rid of that 2 at the bottom, and maybe that's easier for you. So we get 20n squared nonetheless, minus 380n, and my pen always does funny things when I'm in a rush, plus 1,680. All right, now this trinomial does simplify. You guys are going to have to take my word for it at this point. To n squared minus 19n plus 84 equal to 0. And I factorize it into n minus 12 n minus 7. And in this case, I get 2 answers that are actually positive. I get 12 and 7. Now, the question did say, why does he get, he was puzzled that he got 2 values. Now, guys, what is happening is the total in his account was the total prize money in his account was 840 Rand on 2 occasions, because as we got past a certain point, because we were giving him less and less and less money every time, what happened is we started giving negative amounts. So in this case, what you will do is you will take the first answer. Now, the one tip that I can give you, if you're finding this hard to comprehend, is go back to the number pattern and keep on doing this. Do this up to 7 times and do it up to 12 times, and you'll see what happens. All right, now guys, unfortunately, that is pretty much the only question that we have time for. Just to talk to you guys quickly about the last question. The last question says, after, let's say, 20 days, I don't know how many days it was, he's suddenly alarmed because the amount in his account is dropping. That is because of the fact that the sequence is dropping. Investigate that. Over to you, Indy. That's all we have time for.
Okay, guys, at 7 p.m. as the show ends, the competition will be closed for auditions. Our top 10 will be chosen. The top 15, Abram Atik Gemoghetswe, Lelankolina, Luluma, Luniklumo, Megan Tukozo Pumalele, Rachel Sibangojalo, Tareen Taboho Chepo. Good luck, guys. We thought that you are all completely awesome. Watch the page tomorrow for more info on who our top 10 will be. We'll be posting on www.mindset.com, facebook.com/learn extra. Thanks so much, guys. See you same time, same place next week. Bye.